This tutorial video provides an overview of how to run a simple example in Dakota, and look at the basic output that Dakota generates after running. We will first demonstrate how to run Dakota using the command line, and then using Dakota's GUI application. Finally, there will be a brief overview of the types of files that Dakota can generate. Dakota is compatible with most operating systems, including Mac, most variants of Linux, and Windows. For Windows use, we recommend using a modern command line tool such as PowerShell or Cygwin. The first thing you should do after downloading and installing Dakota is to make sure that it runs from the command line. This can be achieved by executing the command dakota -v. If successful, Dakota will display its version information. For the example used in this tutorial, Dakota will explore the Rosenbrock function, using its multidimensional parameter study method to search the function across an evenly partitioned grid of points. This example file is called rosen_multidim.in and is located at the following path, starting from the Dakota install directory. Copy this file to a working directory area for Dakota to run in, such as your home directory. From the command line, run dakota-input rosen_multidim.in-output rosen_multidim.out. The first command line switch, input, will use our rosen_multidim.in file as Dakota's input file. The second command line switch, output, will cause Dakota to write its output to the destination file rosen_multidim.out. There may be a warning message displayed, but it can be safely ignored. 3 files should have been created by executing this command: rosen_multidim.out, an output file, rosen_multidim.dat, a tabular data file, and dakota.rst, a restart file. We will go over each of these files in more detail later. Let's run this same example again, only this time we will use the GUI to demonstrate how to use Dakota. Launch Dakota GUI and choose a workspace. The workspace is nothing more than a directory on your system where Dakota GUI can do work. The first time you open the GUI, you'll be presented with a welcome screen. Click on Search the Dakota Examples repository. We'll use the same rosen_multidim.in example file as we did before, only this time the GUI will locate it for us. Type in rosen and click Search. The GUI will search the examples directory that ships with Dakota to find text matches. Select rosen_multidim.in and then import. A new project will be created that contains this Dakota input file. Now right-click the Dakota input file and choose Run As, then Dakota. You'll see Dakota's console output running in the console view. Now that Dakota has finished running, 2 files have been created, dakota.rst and rosen_multidim.dat. There will also be a run_results directory created. By default, the GUI automatically makes a backup copy of all Dakota output files in a timestamped directory each time you run Dakota. Let's talk about the types of files that Dakota can output while running. Dakota outputs a large amount of information to help users track progress. Dakota's output file contains information on every function evaluation, so it can be quite extensive, depending on how long Dakota runs for. For the example we just ran, Dakota's output file is organized into 3 basic parts: information on the problem, information on each function evaluation, and summary statistics. For this example, we see that a new restart file is being created, and Dakota has carried out a multi-dim parameter study with 8 partitions for each of the 2 variables. Each function evaluation is numbered. Details for this evaluation show that at x1 equals -2, and x2 equals -2, the direct Rosenbrock function is being evaluated. The section of the output file shown here is repeated as many times as Dakota iterates over the function. The function evaluation summary is preceded by several less than signs. For this example, 81 total evaluations were assessed. All were new, none were read in from the restart file. Correlation matrices complete the statistics and output for this problem. Successful runs will finish with the message Iterator Study Type completed. In addition to the regular output file, Dakota has the ability to record errors that it encounters to a separate error log file. The Dakota restart file is a binary file that can be used to restart Dakota if the process was interrupted. Using a restart file, a user can instruct Dakota to resume where it left off, without losing all progress. Dakota's tabular data file is a space-delimited text file that summarizes the inputs and outputs to the function evaluator. The first line contains the name of the variables and responses, as well as headers for the evaluation ID and interface columns. Each line of the tabular data file shows variable and response values collected by Dakota at each iteration. Finally, Dakota can also output its evaluation data to an HDF file. HDF is a structured hierarchical database format used in scientific programming. Dakota's HDF output can be explored using a number of available tools, such as H5Py for Python command line use, or the HDF team's own HDF View tool. The Dakota GUI is also capable of exploring HDF files without the need to switch tools.